Hello, so this is problem number 4 of the exam 1 review problems that I posted on the week 5 recitation worksheet. So here we want to solve the following differential equation. So if you've looked at like a lot of the methods we have for solving these so far, oftentimes we want to put these equations in a form where y prime or dy dx, or maybe if we're flipping things around, dx dy, we want to put these, we want to get this y prime sort of separated. So if you remember homogeneous equations, they were of the form dy dx, or sorry, not homogeneous equations, linear first order equations. They were of the form dy dx plus p of x times y equals q of x. So sometimes a good trick to maybe think, if you look at an equation, you're like, oh, I'm not exactly sure what to do with that, maybe try to separate out y prime and see now, once I've done that, does this equation now match a form that I'm used to? So here, if we divide by x squared on both sides, we would get y prime is equal to y over x plus e to the y over x. And so now this is in the following general form, where dy dx is equal to some function f of y divided by x. So notice here, we can kind of think of it as a function of y divided by x because every term containing variables here, y and x appear in this fraction. So this is a homogeneous equation. The way we solve this is by making the substitution v equals y over x. And what this does is it transforms our equation into what should be a separable equation, x times dv dx equals f of v minus v. So working with our function f here and this substitution, we would get x dv dx is equal to v plus e to the v. So this would be f of v minus v. And so we can simplify this a little bit. E to the v. And then we can separate the variables to get dv times e to the negative v is equal to 1 over x dx. And now we can integrate both sides. So here the integral of e to the negative v is just negative e to the negative v. And that's equal to the natural log x plus c. So what we can now do, we can do the sort of trick where we bring the c inside the natural log. And to make my life easier before I'm about to take the natural log, both sides, I'll rewrite this like so. And so from this equation, what I can do is I can now take the natural log again of both sides, so many natural logs, to get that negative v is equal to the natural log the negative natural log of c times x. Well, v, remember, was equal to y over x, so we get y over x is equal to the natural log of the natural log of cx. And so now we can just bring over a negative x to get that y is equal to x times the natural log of the negative natural log, of cx. So a few things to note here with this problem. Again, last two problems each, we've wanted to sort of, in a sense, separate out dy dx or y prime from the rest of the problem. So maybe a good thing to do is, if you see this, kind of divide through by whatever you need to divide by to separate out this y prime, then analyze, okay, what form is this in? If all of the variables look like y over x, then maybe we can do this substitution, which we know will always transform our differential equation into something that looks like this, which, if this process worked out as it should turn into a separable equation. Things to not forget: don't forget to substitute for v at the end. So yeah, that would be sort of an example of a homogeneous equation.